Let's look at this problem. What is the area of the triangle formed by the lines of y equals 5, y equals 1 plus x, and y equals 1 minus x? In order to have a better understanding of this picture, we got to draw a diagram to get the three lines out. Then you know that it's not very hard to compute the area of the triangle. So let's do it. The coordinates should be like this. Alright, let's say this is the x-axis, this is y-axis, and then this is 0, right? So let's assume that's 5. And we'll draw a line here. This is 5, right? This line is y equals 5. And then let's draw this line y equals 1 plus x. And we know that the line for y equals x should be like this, right? Diagonally. And for y equals 1 plus x, that's simply moving this line up by 1 unit. Or you can think of it in this way. We can simply compute the intersection of this line with the two axes. So that's also an easy way to understand how the line looks like. So in that scenario, when y equals 0, x equals -1. -1. And when x equals 0, y equals 1. So let's connect these 2 points. We'll get the line. Right? Good. So this is the line of y equals y plus x. And similarly, we can draw the third line. So we can either, produce that line by moving the line y equals -x up or down. In this case, it's up by 1 unit. Or we can get the intersections. So we'll do the intersection way. By the same principle, when x equals 0, y equals 1. So that's this point again. When y equals 0, x equals 1. So the intersection on the x-axis is here. So we connect these two lines, right? Let's connect these two lines. Alright, so this line is y equals 1 minus x. So let's call this intersection A. Let's call this intersection B. This intersection C. Good. So all what we need to do is to compute the area of this shaded part. That's the triangle formed by the three lines. And up to this point, there are actually quite a few ways to handle this. So there are like analytical way by computing, the coordinates of the points, or we can do a pure geometric way. Let's do it in 2 ways, just to illustrate, how to do the computing. So let's say method 1. In method 1, we are going to compute the coordinates of the point B, this B, right? So for this B, that's the intersection of these two lines, right? So what we need to do is to put them together to form a equation system. So y equals 1 plus x, and the y equals 5. Then we can replace this y by 5, right? So 5 equals 1 plus x. Therefore, x equals 4. Then we know that this coordinates of point B is 4 and 5, right? So that means this part, the length of this part is 4. And by symmetry, this part is 4 as well, right? Then how about this part? What's the length of this? That's the height of the triangle ABC on side AB, right? And that length is 4. Good. So now we are ready to compute the area of this triangle. The area of triangle ABC equals a half times the length of the base, that's AB. We use AB as the base, that's 8, 2/4, right? Then times the height, that's 4. Therefore, that equals, cancel the 2 with this, and 4 times 4 is 16. Therefore, our answer is E, 16. Now, before we end this video, let's introduce a second method, which is using the pure geometry knowledge. And by the fact that AB is parallel to the x-axis, right? Then we know that, let's denote this point. This is D, and this is E, right? Therefore, we know the triangle CDE is similar to triangle CBA, right? And it's very easy to prove that, right, by tracing the angles, because these two angles are the same, these two angles, and this angle equals this angle, right, by the fact that these two lines are parallel. Good. So these two triangles are similar. Then what's the ratio of the pair of triangles? We know that the height, this part, I'll use a different color, this part, that's 4, right? And this part is 1. Therefore, the ratio of these two similar triangles is 1 to 4. That's the smaller one to the larger one, 1 to 4. Good. Now, let's calculate the area of the smaller triangle, CDE. Why is that? Because all the needed segment length is ready. We know that x-axis for point D is -1, and for point E is +1, right? Therefore, the length of the base, DE, that equals 2. Therefore, it's a half times 2 times the height, and we said that's 1. Therefore, the area of triangle CDE is 1. And since these two triangles are similar with a ratio of this, therefore, the area of triangle CBA, which is the shaded area, right, that equals the area of the smaller triangle CDE times the square of the ratio, so R square, right? And it's a 4 to 1 because it's larger to smaller. And this is 1, this is 4 square. Therefore, that's 16. So we get the same solution, 16 as well. If you like this video, please give it a like and subscribe the channel. If you have questions, please leave a comment.